From what they are to how many of them are in the universe and more, join me as we explore what red dwarf stars are. If you were to look at the night sky, you'd see a bunch of stars. But from where you are, you might not be able to see that there are actually all different kinds of stars in the sky, and yet you can only see certain types via the amount of light they produce. Yet what might surprise you is that the most populous of these stars are the ones that don't have a lot of light, but have a lot of life. These are known as red dwarf stars. To be clear though, if you try and give a red dwarf star a definitive definition, you're doing yourself a disservice, as Red Dwarf Star is more of a title than a classification. There is no true definition of red dwarfs. Astronomer Michael Guillon of the University of Liège in Belgium told Space.com by email. Guillon, who studies stellar objects at the cooler end of the spectrum, was part of the team that identified the ultra-cool star TRAPPIST-1. Red dwarf generally refers to dwarf stars with a spectral type ranging from K5V to M5V, Guillon said. Oh, and in case you were wondering about the long life aspect of things, because of the variety of red dwarfs and how they're composed for the most part, they are indeed the longest lasting stars in the universe, to the extent that if you were to make a model of the universe in its last days, more than likely the last star to survive would be a red dwarf. Pretty cool, huh? But let's back up a bit, shall we? Let's start looking at the red dwarfs at their most basic of elements. Starting with, how many of them are there in the sky above? Well, of the known universe, we believe that about 70% of all stars in the sky are red dwarf stars. That's right, if you take all the other kinds of stars, including our own sun, which is a yellow dwarf star, and combine them, you only get 30% of the stars in the universe. Bet you didn't see that coming. What you also likely didn't see coming is that they are the smallest kinds of stars in the galaxy. Brown dwarfs, for the record, are smaller by they themselves aren't called stars because of their size. So 70% of the universe is made up of really tiny stars that you likely aren't seeing when you look up at night. But just how small are they? Well, if you compare them to our own sun, they can range anywhere from about 50% of its mass all the way down to about 7% of its mass. That's another reason why a red dwarf star isn't describing a singular type of star, because the range of sizes it includes covers a lot of ground. And remember that line about likely not seeing them in the night sky? Well, you honestly haven't seen one in the night sky without the aid of a telescope or other special device, as the red dwarf star type is known for being very dim in its light output, so much so that it's impossible to see it at night with the naked eye. Furthermore, despite having all sorts of probes, satellites, telescopes, and other space charting technology, we can only see red dwarf stars within a certain range of Earth. To that end, we know that there are around 20 to 30 red dwarf stars within our immediate area. Obviously, that means outside of our solar system, but still that's a good amount of them. And again, they are the longest lasting stars in the universe. But how is that possible? That would be because of the way they create their heat and light. If you observe most stars of the non-red dwarf variety, you'll see that they are constantly making gases via nuclear fusion reactions. They transform hydrogen into helium and burn it to become the bright balls in the sky. Red dwarfs technically do that, but in a more roundabout manner. Mainly instead of instant reactions, they go and do convection heating, meaning that the hydrogen and helium mix around on a loop, allowing the gases to burn much slower. The lifespan of a star depends on the burning of its gases. Most stars last billions of years because of their fusion reactions, but with red dwarf stars, because they burn so slowly, they can last anywhere from 1 trillion to 10 trillion years, based on our understanding of its composition. If you keep track of how old the universe is, that means that every single red dwarf star that was born when it was created roughly 13 plus billion years ago, if you believe in the Big Bang Theory at least, is still around outside of interference from other stars, black holes, etc. And those same stars will be around long after humanity and possibly all other life in the universe has died out. It's a depressing thought, but it shows once again just how long these stars can last. Before we dive even deeper into what red dwarf stars are, be sure to like the video and subscribe to the channel. That way you don't miss any of our weekly videos. So let's ask ourselves the big question here, okay? Could we possibly live on a planet that circles a red dwarf star? I mean, we know there are planets that are orbiting red dwarfs. We've found more than you might think. And some of them have even been confirmed to be kind of a rocky planet, meaning that they have a solid surface and aren't just a gas giant. By that token, if certain factors line up our way, we could totally live on that planet around the star, right? Well, maybe. But let's just say that not unlike Earth, we need a lot of things to go our way in order to make things work. As noted, red dwarfs don't have the mass of our own sun, which in many ways is the perfect sun for Earth to be around and orbiting. And because it doesn't produce as much heat or light, as it burns nearly 2,000 degrees Kelvin cooler than our own sun, that means there are a few issues we'd have to deal with right off the bat. We'd have to be really close to the red dwarf star in order to even attempt to live around it. Most scientists speculate that because of the output of heat and light, that they'd likely have to be around the distance of Mercury from our own sun in order to live there and get what we need from the red dwarf. If you don't know, Mercury's abnormal orbit around the sun means that it can be anywhere from 28 million miles away to 43 million miles away. But let's just shoot for the middle and say that our new home would have to be about 35 million miles away from the star. That's 60 million miles closer than Earth is from our sun right now, and that would raise a few issues. What's the first problem? That would be position of the planet, not in terms of orbiting the star, we already figured that out, but because of its proximity. Just like Mercury, the planet we would go to would likely be tidally locked. To be tidally locked means that the planet would be literally cut in half in terms of exposure to the heat and light. 9 times out of 10, a tidally locked planet is burning hot on one side of the planet and then freezing cold on the other because of the lack of exposure on one side and the overexposure on the other. This causes some really extreme planets, and obviously that would make living on said planet nearly impossible. That being said, there are those who believe that if done correctly, the planet that orbits a planet this way with a large enough ocean, maybe even something like Earth is now, could distribute that overexposure of heat and allow us to be able to live on the planet in a more sustainable way. But again, that's just a belief, a theory. It's obviously not been proven because we haven't found a planet that has done it yet. Here's another problem. Yes, there are many more problems to talk about. Because of the distance from the planet to the star, there's a chance that the red dwarf's gravity would start to constrict the planet in such a way that it would shrink. This is actually something going on with Mercury right now, as it shrinks every year it's around the sun. Why does that matter? That would be because if you shrink something down, it gets more compacted, and that can make things even hotter via its core temperature. If that happens enough, then the ocean's temperature will start to rise, and when that happens enough, that would mean that the oceans will boil, then evaporate, and then be gone. And when that happens, the planet will basically turn into Venus. If you recall, Venus is a greenhouse effect planet that is so hot that its surface is many hundreds of degrees and is capable of melting most metals that try and land on it. Obviously, this is a no-go in terms of a planet that we hope to live on. Think we're done with the problems? Nope. We've still got one major one to talk about, and it's one that we've mentioned before: variety. As noted earlier, red dwarfs come in a variety of shapes and sizes, from ones that are really small to ones that are about 50% of the sun we have. Because of this, it's really hard to say whether living near a red dwarf is possible because there are a ton of them and they don't act the same or even look the same at times. What do I mean by that? Well, there are certain kinds of red dwarf stars that have spots on them. Think of it like the red spot on Jupiter that is a defining feature of the planet. On a red dwarf, these spots, which are usually black, can help dim the star's output of light and heat, hurting the planet that is potentially being given life by it. Or the red dwarf can have events known as solar flares, which can ravage a planet if they get too hot. Think about Mercury. And even if there was an atmosphere around the planet, the proximity of the planet to the star would ensure that the atmosphere would be obliterated, with all life on it following soon after. So given all of that, life on a planet near the red dwarf would be very tenuous. Not impossible, but it would be a very long shot to find the right amount of circumstances to make it work. Then again, that sounds like Earth, so maybe it's not as impossible as we think. Especially when you consider that because there are so many red dwarf stars in the universe, and that there are plenty of moons, planets, and more circling them, it might just be a matter of time before we find something that we like. To give you a round number, it's believed that there are about 60 billion bodies between rocky moons and planets circling red dwarf stars just in the Milky Way right now. And if we were to find one that is the perfect set of conditions, we could stay there likely until the end of time, so long as it's between 1 to 10 trillion years, which, given how old the universe works, that's a pretty safe bet that we can live before the end of time happens. Now obviously, this isn't a case where we can just find the planet and or moon around a red dwarf and say, hey, let's go now while the getting is good. Because we can barely leave Earth right now with a few people on a craft, let alone spaceships that can hold hundreds, thousands, or even millions of people. We still need to work out the traveling at warp speed. Engage! In order to reach some of these dwarf stars. And that's for the ones that are just relatively close to us. Imagine if this potential habitable planet was one that is on the other side of the Milky Way galaxy. Think of all the distance we'd need to travel in order to make that work. This isn't meant to depress you, rather it's meant to show you that it's going to be a while before we can even think of moving to a planet or moon around a red dwarf star. Not that this is a bad thing, because we know that the star is going to be waiting for us while we try and get there, and that is something to take cover in. So to close, what can we truly say about red dwarf stars? They aren't the brightest of the bunch, or the most powerful, and unless you know where to look and how to find them, you're not going to see one outside of books, pictures, and cool YouTube videos like ours. But they are out there, and they're waiting for us to find one that has the circumstances for us to live near them one day. Plus, when the universe dies out, likely many trillions of years from now, it'll be the red dwarf stars that are there to be the last light that goes out. Thanks for watching, everyone. What did you think of this look at the red dwarf stars and why they matter to the universe as a whole? Did you know this much about this kind of star before coming here? Do you think that eventually humanity or another race will be residing around a red dwarf star? Let me know in the comments below. Be sure to subscribe, and I'll see you next time on the channel.